Okay, so we are looking at section 131. And remember, if you're looking for the homework to see what is assigned, always look for practice. It always has 10 problems. It's always going to have 10 problems. That should be the way we're going to navigate it. Okay, so first, this is good because I'm going to look at this number 2. This is workbook 131. Okay, and we're going to look at number 2, which is just this, very similar to number 1. Number 2 just has a little bit more complex of a slope. So let me write this out. The first step is figuring out what your m is and what your b is if we're given this equation. Okay. Now, I'll break this down a little bit better, more thoroughly when we get to the word problems, because there are things you could look for every time to see if you're on track. Okay. So, all right. So if I'm looking at this, first off, right off the bat, this number that's always by itself, that's always the constant out by itself, that is always the b value on the outside here, and this is our y-intercept. So part of this is being able to look at the equation that you have and looking at our basic slope-intercept form of the line and saying, well, what is m? Where is it located in this equation? It's located right in front of the x. This is our slope. So we know that for graphing lines, we only need 2 different parts. We need the slope and we need the y-intercept. Okay. This is how it's always going to be for linear equations. All right. So everyone so far so good? So far so good? All right. So looking at that, we have a little graph here. We can just draw a quick graph. Your graphs don't have to be perfect, guys. That's our y-axis. That's our x-axis. Okay. So first step, every single time. First step, number 1. We're going to plot the y-intercept. Okay. So where is the y-intercept? It's always the number out by itself, our b value here. So we're going to go up 1, 2. 2 is where, so like if this was the line, it would intersect the y-axis here. That would be the y-intercept. If it was down here, it would intersect it down here. It's like an interception, like with playing football. An interception is just where you catch the ball en route, right? You catch it before the other player. So plot the y-intercept. We're going to put it right here at 2. 1, 2. Right? Is that 2? That's always the first step. Step 2 is use slope. They're like steps, right? They're like steps. Use your slope to find your next point. And honestly, from there, you just have to draw your line. Okay? So there's only, you have to know about this. You have to be able to identify and pull out the information you need. And then now look here, the slope is 1/3. Now let's look to see what that means. Remember, our slope is rise over the run. So if we have a slope rise over run, that's 1/3. They're both positive numbers. So if I'm rising, rise is going up and down, up and down. So if I'm rising +1, am I going up? Positive is up. Yep. If I'm running +3, we just have to think, well, from here, where's the positive numbers? Positive numbers are over here. Positive numbers are over here. So based on what my slope is, I could look at this and say, well, 1/3, we're going rise of 1, run of 3. 1, 2, 3. And there is my next point. That was my rise of +1, my run of +3. You see? Rise of 1, run of +3. So this is going to bring it to the right. That's what we did. And now all you have to do is make your line as well as you can through those 2 points that you made. It's all about the step, where you start and what step gets you to your next point. Okay? So for those that I can see, give me a thumbs up, sideways, down. How did that kind of break down? Yeah, it's a good review, right? Just real quick. I think it's good for everybody, so thanks for bringing that up.
I have a question.
Perfect.
On which graph paper am I supposed to graph it? Like it's from workbook, or am I supposed to do it on white paper, right?
No,
I mean graph paper.
Yeah, you'll want to do it on graph paper. What I'll suggest is in the back of the workbook. In the back of the workbook, there are these pages that are just little graphs, and there's about 15 pages in the back of the book. I guess, look, it's at page 131-ish. So grab a few of these pages. You'll need to graph them on some kind of graph paper. These are free. You already have them. Or you can go and buy some graph paper if you like. If you're in class, I have all this stuff free for you guys, but I can't ship it to 160 kids. So I will go ahead and keep doing what I'm doing. Use the graph paper you have available. All right, let's keep going. All right, we did 2. Now let's do 7. Number 7. All right, number 7. This is still in the workbook. This is 1.3.1. So we're going to use some of these rules up here, but when we do the word problems, you're going to see there's one key thing that's going to help us make these easy. Okay, so let's look at number 7. Okay, a water company charges a monthly fee of $6.70 plus a usage fee of $2.60 per 1,000 gallons used. What is the equation that models the water company's total fee? All right, the one thing I'll tell you is this 1,000 gallons used is just a unit measure, and that's not going to be involved. Every single time for number 7 or any of these word problems, every single time, you're going to, number 1, you're going to find the constant amount. So what I mean is, look at this. It says that the company charges a monthly fee of $6.70, but look, plus a usage fee of $2.60 per 1,000 gallons. So the $2.60 per 1,000 gallons, that is the part that could change. That's the part that could be a variable, right? Because think about it. If I use 2,000 gallons, right, and it was $2.60 per 1,000 gallons, then I'm going to have 2 units of that, and I would end up with, what is that, $5.20 for that, right? If I have 4,000 gallons, I would end up with $10.40. So this right here, the $2.60 per 1,000 gallons, that's our variable amount. And then look here, the monthly fee of $6.70 as just your monthly fee is going to be $6.70 for sure, right? This isn't going to change. So think about it. If you guys have a phone plan, right? You pay your basic, that gets you a certain number of minutes. What happens if you go past your minutes? It costs more, right? It charges you per minute you use. So the key here is find the constant amount. In this case, the constant amount is our monthly fee. That's our $6.70. Okay. And then number 2 for all these problems, number 2 is find the variable amount. I'm going to change that word. That's not how you spell it. Maybe. I don't know. Find the varying amount. And that's just the amount, right? That's the amount that changes. The varying amount is just going to be what changes. So since we have $2.60 per 1,000 gallons, and I don't know how many of those 1,000 gallon units I'm going to use, I'm going to say that 2.60, that is our varying amount, because that could change. Okay. Now let's go back and look at what we have for our equation, because now we're going to put it in the equation. Y equals mx plus b. Okay. So if I have a value here for m, which is what we're trying to find, what is m and what is b? If I have a value for m, I would be able to multiply it by some number of x, and this term is going to be varying. It might be different if x is big, if x is 10. It might be different if x is 1, right? So this term right here, this is our varying amount. This right here is always going to be whatever number's there. If b is 10, right, it's always plus 10. There's no way that's going to change. So we're always going to put the constant amount right here, 6.7. It's positive. And the varying amount, 260 per 1,000 gallons. If I get 1,000 gallon amount, then it's 260. 2 would be 520. 4 would be 1040. Okay, so what I'm going to do is 2.6x. But really, I want you to really break it down. If you're looking for a shortcut here, you have to find which one is going to be the constant amount, constant, and which one is going to, I need a better word. I'm just going to put it varies. Oh. Varies. There we go. All right. So if I look at this, let's just go through a couple problems real quick. On number 5, it says, we'll graph this in a second, but I want to just check real quick. The cab company charges an initial rate of $2.50 just to get in for a ride, plus 40 cents for each mile driven. 40 cents for each mile driven. So is the $2.50 the constant, or is the 40 cents the constant? Show me in the chat. Is $2.50 the constant, or is the 40 cents our constant? What do you think? What's our constant? What's going to be in our equation that's going to go right here as our b value for this problem? Good. Jeremy, Evie, good? No. All right, I'm seeing a couple that aren't quite getting it. Yeah. I like that description. The 250 isn't going to change. That's why it's constant. Because here's what they say. Hey, I'll give you a ride, but to get in my car, just to get in and sit in my car before I move, is $2.50, right? You got it now? All right. So the cab company says, hey, for you just to get in my car, for me to even give you a ride, you got to give me $2.50. And then, based on how far you go, right? Because it's not $2.50 to drive from here to, San Francisco if you took a cab, right? It's going to be like 40 cents per mile. It's going to cost a whole lot. This 40 cents is the variable amount, and this right here is our constant amount. So for number 5, I would just write this real quick. I'd say y is equal to 0.4x plus 2.5. Right? All right. If you had that slightly wrong, give me a thumbs up on that, or if you need me to go over that again. But let's go back now and just graph this guy real quick.
I have a question.
Yes, perfect.
So instead of putting like decimals or as a fraction, is that okay?
If you prefer using fractions, the one thing I'll say is in high school math and beyond, you never really see too many mixed fractions. Mixed fractions is pre-high school. Okay. So, if it was a fraction, you could put this as a mixed fraction, right? 5 halves. That is more acceptable. We're not really doing mixed fractions. You could put it as an improper. All right.
Okay.
Yeah. It's just we don't really see that much more anymore. Okay. But decimals, I'd say make sure you're comfortable with them. That is going to be important because some problems just have the decimals. All right. Our constant is our b value. We know that our b value is talking about the y-intercept. It's where you have the interception. Here's the ball that's being thrown, and the interception happens somewhere, the intersection of the y-axis and the line we're going to create is our y-intercept. So let's put it on there, 6.7. 1, 2, 3, 4, 5, 6.7, I'll say is right there. So here's 6, here's 7, 4, 3, 2, 1. Okay, 6.7. Now our this is going to be kind of approximate because our slope right here, slope 2.6 is 2.6 over 1. So I'm just going to go for one more point and I'm going to call it. Okay. Here's how I'd approach it. You could go and say, well, 6.7 plus 2.6, that gives us 9.3. And then you could just find that as how far up you need to go. Because we're at 6.7, we need to go up positive 2.6 and then over positive 1. So I'm here. I'm going to go up to 9.3. So there is 8, 9. See, I'm getting into the bushes here. 9.3 is about here. So I went up 2.6 and then over 1. And it's good enough for me to make my line. Whoops. Okay. All right. If you asked for that question, give me a thumbs up, sideways, down, or a comment. Let me know how that ended up. Okay, we got number 9, and then we'll check in on seeing about our timing here and if it's break time or what. Let's do number 9. All right. Hopefully it's getting a little bit easier now. If you wanted to look through all these problems after I'm done recording this, I'll have 2 through 9 basically worked out in the videos I'll share later. All right, so we have number 9 in the workbook 1.3.1. Okay. So a company started with 3 employees and after 8 months grew to 19. The growth was steady. What is the equation to model the growth of the company's employees? Okay. Let's see. Let me read it and ask you a question. The company started with 3 employees. Is there a way that the company could have started with anything but 3 employees? Is that ever going to change?
No.
Never, right? Right. The company starts with 3 employees. I'm just looking for it. Good. Thanks for the comments. I'm just looking for, hey, what's constant and what might change? What might change? Okay. So let's look at that. We know we're trying to fit it into this equation. And I know my constant is b. So I'm going to take a guess out here. I'm not going to find my slope yet. I'm just going to put this in here and kind of help. It'll allow me to think this out. All right, so we're going to go plus 3 because we're looking to see how many employees we end up when we are adding them together. So let's see. Okay. Oh, that's why this is different. All right, this is a little trickier of a problem. The second part, after 8 months, they grew to 19 employees. Okay. Now this is why this is kind of the harder problem. And it's not the main topic for this, so don't worry if this is still tricky for you. When I look at this right here is going to be our total employees. Okay. This over here is where we started. This was our starting. We started with 3. And then this is going to be our, well, really, we'll just call this our growth. Okay. So let's look at what we do know. We know that after 8 months, we grew to 19. So we're talking about our total here. How many did we end up with at the end of 8 months? We grew to be 19. Okay. So watch what I'm going to do. The total employees after 8 months is 19. Right? Equals, I know it's plus 3 over here. And if I look at this, this is the part that's tricky. Because 8 is not the m value. 8 is not the m value. In general, you can put this here. X in general is talking about time. Okay? X is talking about time. So watch what I'm going to do, and this is why this is a little tricky. All right. My internet, I guess, is slowing down. Hopefully it's not catching. Cover your camera like this if I start stuttering from my signal being bad, okay? So watch. We want to still find our m. We want to find the m, but we know that I've been counting to get to 19 people. I've been working, counting the employees for 8 months. All right. You guys are frozen. Can't tell if you're still there, guys. All right, well, I'm going to keep going. I'm recording this, hopefully you guys are still there. All right, so watch. 19 is equal to, let's just move this around so we have it in a way we're used to seeing it with the coefficient first. No. Okay, I'm back. But I can't see any of you. Hey, there you guys are. All right. Evie, I know if I'm frozen, based on if you keep popping bubbles, chewing your gum. When I see the bubble popping, I know I'm not stuck. So thank you for being my time guide. All right, so let's look at this. I think I'm still recording. Let's see. Now I need to share screen again. All right, let me do that real quick. Sorry, guys. We got to roll with all these tech difficulties. That happens, right? It happens. All right, and I'm still recording. Perfect.
I'm sorry, but
okay.
I barely hear you.
Anybody else having trouble hearing me? All right, let's do a built-in microphone. This.
Yes.
Okay, that's better, right?
Yes.
All right. Yeah, I know it's glitchy. I have good internet. I don't know what's happening. I'll do my best, guys. We'll do our best. This is why online learning is difficult. All right, so the Zoom failed us, so I'll just finish this this problem so that we can I'll give you instructions, okay, guys, in the stream when this stuff happens. Okay, we were just trying to find what M was. This was a weird problem because we know that after 8 months it got to 19. So 19 is my total employees, but X is always talking about time, so I know my X value had to be 8 months. Now I put that in there, I work it out, coefficient first, then variable, plus 3, and now I just need to solve for my equation. 16 is equal to 8m. So we know that when we divide by 8, m is 2 over 1. So really we have this equation. Let's bring it back to this one up here, bring it down, right? So we're using our original equation up here. Let's bring it down. Y is equal to 2 over 1 x plus 3. Now I put 2 over 1 just because it's going to help us quickly find our slope. Y-intercept is always out the constant by itself. 1, 2, 3. Done. Then we make our steps using the slope. Our slope is right here. And we're going to go up to over 1. Up to over 1. And we have our line. Okay. So this was a little bit of a harder problem. And, looking at this, the main difference with this was that X is talking about time. So when we're talking about 8 months, after 8 months, we got to put in 8 units here. Okay. So looking at this equation, if this was after 8 months, it'd be 2, right? Times 8, that's just 16. Plus 3, 19 employees. We got it. Okay. All right, that's it. I'll go and post these, and my video is already posted for today's lesson from the other class. So that should get you going. You should be able to do it.